Let's be clear about what this is before we start, because the question can be read two different ways and only one of them is interesting. This is a hypothetical. Humans did wear clothes, we have been wearing them for a very long time, and nothing here is describing something that actually happened. What we are doing is running a thought experiment. Take one specific technology out of the human toolkit, leave everything else alone, and follow the consequences as far as the evidence allows. The second thing to be clear about is that this is a question about anatomically modern humans and their recent ancestors, not about the whole hominin lineage. Our lineage went without clothing for an enormously long time. Successfully. The interesting part is what changed when that stopped being viable. And the answer, once you follow it properly, is not modesty. Take clothing out of human history, and you do not get a world of naked people otherwise living normally. You get a species confined to a narrow band of the planet, with a fraction of its population, missing several of its largest technologies, and with entire continents never reached at all. Let's dig into this properly, because to see why, you have to start with a much older question. Why we needed clothes in the first place. Humans are a strange mammal. We are effectively hairless across most of the body, which is unusual among land mammals of our size, and especially unusual among primates. Chimpanzees, gorillas, orangutans, and every monkey species are covered in fur. We are not. We did not lose our fur recently. Genetic evidence suggests it happened deep in our lineage, likely over 1 million years ago, well before our species existed. One line of reasoning comes from genes involved in skin pigmentation. A furred ancestor does not need heavily pigmented skin because fur provides the protection. Dating the emergence of genetic variants associated with dark skin gives an approximate window for when bare skin became the norm, and that window is very old. Why it happened is debated, and several proposals are taken seriously. The leading one involves heat. Our ancestors were active in open, hot African environments, and moving during the heat of the day generates a great deal of internal heat that has to be shed. Humans shed it through sweating, and we do this on a scale no other primate approaches. We have millions of eccrine sweat glands distributed across the body, and we can lose an extraordinary volume of water through the skin. Fur interferes with that, since evaporation works best directly from skin. Losing the fur and gaining the sweat glands appear to be part of the same package. This connects to a distinctive human capability. Humans are poor sprinters and exceptional distance movers. Over long enough distances in hot conditions, a person can outlast animals that are far faster, because most large mammals cool by panting and cannot pant effectively while running. Some researchers have argued this underpinned a hunting strategy of pursuing prey until it overheated. The idea is contested, its role in actual ancestral hunting is debated, and the ethnographic examples are limited. But the underlying physiology is not in dispute. A second proposal focuses on parasites. Fur hosts ticks, fleas, lice, and mites, all of which carry disease. Reducing fur reduces habitat for them. Related work has proposed that once humans had less fur, clothing later provided a partial substitute that could be removed and cleaned, which fur cannot be. Whatever the mix of causes, the result is a species with excellent cooling and almost no insulation. In the tropics, that is an outstanding design. Outside the tropics, it is a serious problem, and this is where clothing enters. Let's talk about when that happened too, because the evidence comes from an unexpected direction. Clothing rots, hides, furs, and plant fibers decompose, and the archaeological record for early clothing is close to empty. Stone tools survive by the million. The garments they were used to make survive essentially not at all. So researchers went looking for a proxy and found one in lice. Humans host several louse populations, including head lice, which live in scalp hair, and body lice, which live and lay eggs in clothing rather than on the body, moving on to skin only to feed. Body lice are therefore entirely dependent on clothing. No clothing, no body lice. That makes the divergence of body lice from head lice a rough marker for when clothing became a regular part of human life. Genetic studies estimating that split have produced dates ranging widely. generally somewhere in the range of tens of thousands to well over 100,000 years ago. The estimates vary considerably depending on method and assumptions, so this is a broad window rather than a precise date. Physical evidence lines up loosely. Hide-working tools such as scrapers are very old. Eyed needles made of bone, which allow real tailoring rather than simple draping, appear in the archaeological record from roughly 40 to 50,000 years ago, with some of the oldest examples from Siberian sites. There is also evidence that Neanderthals processed hides and used some form of covering. The distinction between draped and tailored clothing matters enormously for our thought experiment. A hide thrown over the shoulders helps a little. Fitted garments with sewn seams, sleeves, leggings, closed footwear, trap air against the body, and are a completely different order of protection. Serious cold is survivable only with the second kind. Let's talk about skin too, because this represents a consequence that follows directly from the geography and is easy to overlook. Losing fur-exposed skin to direct sunlight in equatorial Africa, where ultraviolet radiation is intense year-round. That exposure creates real problems. UV damages DNA and raises skin cancer risk, though cancer typically strikes late enough in life that its selective pressure is limited. The more significant issue involves folate, a B vitamin required for cell division and for normal development during pregnancy, which is degraded by ultraviolet light circulating in blood near the skin surface. Heavy pigmentation is protective. Eumelanin absorbs and scatters UV, and populations indigenous to high UV regions have consistently high levels of it. That is the ancestral human condition, and it appears to have arrived alongside the loss of fur. Moving away from the equator reverses the pressure. At high latitudes, UV is weaker, particularly through long winters, and skin needs some UV exposure to synthesize vitamin D, which is required for calcium absorption and bone development. Heavy pigmentation in a low UV environment can impede that, and the depigmentation seen in populations native to northern regions is generally explained as a response to this constraint. The genetics turn out to be complicated, with different variants involved in different populations and some of the relevant changes appearing surprisingly recently. Clothing sits right in the middle of this. Covering the body blocks UV as effectively as pigment does, which means clothed populations at high latitudes faced an even tighter vitamin D squeeze than bare skin alone would have produced. Some researchers have argued this intensified selection for lighter skin considerably. In our thought experiment, none of this happens. Nobody leaves the high UV zone, so nobody experiences low UV selection, so depigmentation never occurs. The enormous variation in human skin color, which is largely a record of where our ancestors' ancestors were standing relative to the equator, collapses into a much narrower range. Now we can run the experiment properly. This detail is worth sitting with directly because it is the largest consequence by far. Without clothing, humans stay in the tropics. There is no way around this. A human body without insulation, in sustained cold, loses heat faster than metabolism can replace it. Fire helps, but fire is fixed in place and you cannot carry it while hunting or traveling. Shelter helps, but you have to leave it. The margin for an unclothed person in a temperate winter, let alone an Ice Age one, is measured in hours. It is worth asking whether biology could have compensated, since evolution does sometimes solve problems that technology otherwise handles. Human populations living in cold regions do show some physiological adaptation. Differences in body proportions consistent with heat conservation, variation in how blood vessels in the extremities respond to cold, and differences in metabolic response. Some populations show notable cold tolerance in specific tissues. But these adjustments are modest against the scale of the problem. They shift the margins rather than removing the constraint, and none of them approaches what a fur coat provides. Mammals that live in truly cold environments carry dense insulating fur or thick fat layers, and both take a very long time to evolve. Human expansion into the north happened far too quickly for anything like that. The archaeological picture shows people arriving in cold regions and surviving there within timescales measured in millennia, which is a technological response rather than a biological one. That is the crux of the whole scenario. Our lineage traded insulation for cooling capacity, committed hard to that trade, and then walked into environments where the trade was catastrophic, carrying a solution made of hide and thread rather than growing one. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. So the map contracts drastically. Africa, Southern Asia, parts of the Middle East, island Southeast Asia, Northern Australia, the warm belt of the Americas. Assuming you could get there, which you could not. There is a further wrinkle worth naming, which is that fire and clothing are not fully independent solutions. Fire requires fuel, and fuel in cold regions means wood, which means forest, which does not extend to the far north. Tundra and steppe environments offered limited fuel, and people living there relied heavily on bone, dung, and rendered animal fat for burning. Under those conditions, the fire option weakens precisely where the cold is worst, leaving clothing carrying almost the entire load. Shelter runs into a related problem. Building an insulated structure in a treeless environment requires materials. Hides stretched over frames made of bone or driftwood, or snow itself. And constructing any of that means spending extended time outdoors in the cold, doing detailed work with your hands. You cannot build the shelter that would keep you alive without first surviving the conditions the shelter is meant to protect you from. Clothing is what makes the construction possible in the first place, because the route into the Americas ran through the far north. Whatever the precise details, and there is active debate about timing and coastal versus interior routes, human movement into the Americas required crossing high-latitude terrain in extremely cold conditions. That crossing is impossible without tailored clothing and footwear. 2 entire continents go unpopulated permanently until some other species solves the problem. Northern Eurasia goes the same way. Ice Age Europe, Siberia, and the northern steppe all require serious cold weather gear. Every culture that developed there never exists. Australia is a more interesting case, since reaching it required open water crossings, but the destination is warm. Watercraft would still be needed, and watercraft connect to fiber technology, which we will get to shortly. Let's talk about the everyday protective functions too, because this represents a set of benefits that operate even in climates where warmth is irrelevant. Skin is tough, but not armored. Bare legs moving through dense vegetation collect cuts, scratches, and thorn punctures, and each of those is an entry point for infection in a world without antiseptics or antibiotics. Footwear is the clearest case. Bare feet on rock, thorn, ice, or hot sand impose real limits on how far and how fast a person can move, and foot injuries are disproportionately dangerous because they immobilize you. The oldest surviving footwear is only a few thousand years old, but skeletal evidence involving changes in toe bone robustness has been used to argue that some kind of foot covering was in use considerably earlier. Insects are another. Covering reduces bites, and bites transmit an enormous share of the world's disease burden. Long clothing remains one of the standard recommendations for reducing exposure to mosquito-borne illness precisely because it works. Sun protection matters too, even for heavily pigmented skin, since sustained exposure at high intensity still causes damage and drives water loss. Loose covering in hot desert environments is a well-established strategy that reduces solar gain while allowing evaporation, which is why traditional clothing in many hot regions is more covering rather than less. And carrying capacity is worth mentioning, since garments provide places to put things. A person with pockets, pouches, belts, and slings can transport tools, food, water, and infants far more effectively than a person with only 2 hands. That sounds minor, and is not. The ability to carry is one of the underrated foundations of human foraging. So even in the tropics, where survival without clothing is entirely possible, Clothing still buys a meaningful amount. The difference is that outside the tropics, it stops being an advantage and becomes a requirement. Let's talk about what that contraction does to everything else too, because this represents the second order effects, and they compound. Population is the first. A species restricted to a fraction of the planet's land supports a fraction of the population. And for most of human history, population growth and technological development were linked, since more people in more places means more independent attempts at solving problems and more opportunity for ideas to spread. Agriculture is the second, and it is severe. Domestication happened independently in several regions, and some of the most consequential centers were in temperate zones. The wheat and barley package of Southwest Asia, millet and rice in China. Tropical agriculture is real and important, with roots, tubers, and tree crops domesticated in multiple regions, but the specific cereal-based systems that supported the earliest dense populations and the first cities are heavily temperate. Removing those regions removes those trajectories. Let's talk about the technology chain too, because this represents the consequence people never anticipate. Making clothing from hides requires scraping, cutting, piercing, and sewing. Making clothing from plants requires something much more elaborate, separating fibers, twisting them into thread, and interlacing that thread into fabric. That skill set does not stay in the clothing department. Twisting fiber into cordage gives you rope. Rope gives you binding, hafting, traps, and the ability to build structures. Interlacing gives you baskets, mats, and nets. Nets transform fishing and small game hunting more than almost any other simple technology. Weaving on a larger scale gives you sailcloth. Sails matter enormously. Long-distance maritime travel, including the settlement of the Pacific Islands, depended on rigging and sail technology built from processed plant fiber. Without a strong tradition of fiber processing, the entire maritime chapter of human expansion looks radically different. Textile production also became one of the largest industries in the ancient and medieval world, occupying an enormous share of total labor, particularly women's labor, across many societies. It generated trade routes, drove demand for dyes, and created some of the earliest large-scale organized production. And it drove industrialization. The first mechanized factories in Britain were textile mills, and the defining inventions of that early period, the spinning jenny, the water frame, the power loom, were all built to solve textile problems. The demand for cotton to feed those mills is inseparable from the expansion of plantation slavery in the Americas, a system built on the forced labor and suffering of millions of enslaved people, which should be stated plainly rather than folded quietly into an account of industrial progress. Whatever else that history is, it is not a footnote to a story about fabric. Take fiber technology out, and that particular path to industrialization does not exist in that form. Let's talk about the social side too, because this represents the part the question usually gets asked about, and it turns out to be the least dramatic answer. Clothing carries information. It signals status, wealth, occupation, marital status, region, religious affiliation, and group membership, and societies have regulated it heavily. Sumptuary laws restricting who could wear what were common across many periods and places. But that signaling function is not dependent on clothing. Humans mark themselves in a great many ways: tattooing, scarification, body painting, jewelry, hairstyling, teeth modification, and ornaments of every kind. All of these are ancient and widespread, and in societies where minimal clothing was worn, these carried the full weight of social signaling. The modesty framing also does not survive scrutiny well. Norms about which parts of the body must be covered vary enormously across cultures and across history, and many societies in warm climates traditionally wore very little without any sense of transgression. Attitudes here are learned rather than universal, which means the specific taboos of any one culture tell you about that culture rather than about human nature. So in a world without clothing, social signaling would be roughly as rich as it is now, just written on skin instead of cloth. Let's zoom out and pull all of these different threads together. Strip clothing out of human history and the outcome looks something like this. Humans remain a tropical species, distributed across Africa and warm parts of Asia and possibly Oceania, with the Americas and northern Eurasia empty of people. Population is a small fraction of what it became. Skin pigmentation stays uniformly dark, since the depigmentation found in northern populations is tied to low UV environments those populations would never have entered. Fiber technology develops weakly or not at all, taking cordage, netting, sailcloth, and eventually mechanized textile manufacture with it. Agriculture develops in tropical forms only. Social identity gets expressed through ornament and body marking rather than dress. That is not a minor variation. It is a different species history. The underlying point is that clothing was never primarily about covering up. It was a portable microclimate, a way to carry survivable conditions with you into places your body had no business being. Humans lost their fur in a hot place and then invented a removable, adjustable, repairable replacement, and that replacement is what allowed a tropical ape to occupy deserts, tundra, mountains, and eventually orbit. Which leaves an interesting thought worth sitting with. Of all the technologies humans have built, the one that opened up the most of the planet was not the wheel, the boat, or the plow. It was learning to make something warm enough to wear, and every place you have ever lived probably depends on it.